Today we're talking about terms, and we were working with expressions previously, combinations of numbers, variables, and operation symbols, and we've been adding and multiplying integers. Today we're going to kind of use both adding and multiplying and see how can expressions with the same numbers and operations have different meanings. Okay, and does the order in which we do the operations matter? All right, so we're going to look at one expression. We're going to start this one with thinking about Cecil and his tightrope. Okay, so first, let's go ahead and set this up. This is page 17 of our toolkit, and this is lesson 3.1.1, first lesson in chapter 3. We are titling it Terms. And let's start with defining the word term. Put that in the margin. So a term is a number, or it can be a group of numbers. Okay, and in previous lessons, we learned that a group of numbers basically means a product of numbers. We kind of rephrased multiplication like 3 times 2 as 3 groups of 2. Okay, so we're going to call this product. Okay, so group of numbers, or product, or it's a number itself. So we're starting with the expression. So this is problem 1a. We have 4 times 2.5, this is a multiplication, plus 1. Okay, now if we were to want to show this using the arrows, okay, in other words, Cecil was going to do this operation, this routine on his tightrope, what would be his first step or his first group of steps? All right, and the answer should be, well, this means 4 times 2.5. That means 4 groups of 2.5. Okay, so that means his first step is going to be 2.5. And then his second step, since we've only done one group of 2.5, his second step and third step and fourth step are all going to be 2.5. Okay, so this gives us 4 times 2.5, or in other words, 4 groups of 2.5. And then his last step would be 1. Okay, so looking at all these steps and trying to figure out, well, what does this equal? You know, we're not necessarily thinking with the order of operations, where do we add or multiply first? We know we multiply first. But when we're doing these groups of steps, you had 2.5, 2.5 right there, that's 5. And then this is another 5. We can kind of see the visual. So 5 and 5 and 1, that's equal to 11. So that's one approach to operations like this. Okay, now the book poses a new problem, said, well, here's another diagram that Cecil's doing. What would the expression be for this diagram? Okay, so let's think about it as we are putting this in our notes. So our first step is going to be this. Our next step is going to be 1. Then our next step is 2.5. And then our next step is 1. Next step is 2.5. And our next step is 1. Next step is 2.5. And next step is 1. So what would that be as a numerical expression? Okay, so unlike the first one, we don't have groups of 2.5 where they're all kind of grouped together. But one similarity is we do have 4 of those 2.5. Okay, and this 1, instead of being that solo 1, it looks like we have several 1s. So can we call this a number? We can say 2.5 plus 1 plus 2.5 plus 1 plus 2.5 plus 1 plus 2.5 plus 1. But if we're grouping things, what seems to be a group that is repeating itself? And you should say, well, we have this as a group, which is then repeated. and then this is repeated again, and then this is repeated again. And what's repeated is 2.5 plus 1, right? So 2.5 plus 1 is repeated, so it's grouped 1, 2, 3, 4 times. So that gives us 4 groups of 2.5 and 1. Okay, and the difference here is even though we have the same numbers and the same operations going on, the addition and the multiplication, right? Multiplication, multiplication, addition, addition. We have a different value. So let's look at what this would give us. So we have 2.5 and 1, that's 3.5, 3.5, oh, that's 7. And then 3.5 and 3.5, that's 7 again. So it gives us a completely different value. So now we have that equal to 14. And the difference is, in this case, the 1 is not part of the group. We have 4 groups of 2.5 only. And in this case, the 1 is part of the group. In other words, it's part of the product. Okay, so let's put that connection right there. So 1 is part of the product. In this case, the 1 is not part of the product. All right, so let's look at a next example. So this is the same one, but in this case it says, well, what if the 1 came first? If instead of 4 groups of 2.5 and 1, would that change the value of that first expression? Okay, so if we took that 1 and we put it here, would we not get 11? Okay, so we put that 1 here, we would get 1 and then 5 and then 5. That would still be 11. So that plus 1 could be 1 plus this. Okay, and that wouldn't really affect it. So this next expression that we're going to evaluate, we're going to put this in a diagram with the arrows, and let's see what it gets us. So we have problem 2 in the book. And we have an 8 plus 2 times 6.48. Okay, now this is going to help out when we have expressions that are a little bit more complex with decimals and easier ways to deal with those more visually. So let's look at the diagram. Our first step is going to be 8. Our next step, not a 2, because this is a product. 2 times this, right? This is a group. So we now have 2 groups of 6.48. So our next step is going to be 6.48. 2 groups. So we know what one group looks like. All we got to do is copy that into another group. And now we can add them. Well, 6.48, 6.48. That's 12.96. And then we add 8 more to that, and we get 20.96. So it gives us a little bit easier way to add those visually using a little bit of mental skills. Problem B is now, well, let's put the 2 there, and then plus 8, and then put the 6.48 there. So are we going to get the same product, the same diagram, the same end result? All right, so let's see what the diagram looks like. So our first step, is it a 2, or are we looking at groups of something? This is actually a 2 because it is a number by itself. Okay, it's not a product, it's not a group. We don't have 2 groups, we just have the number 2. And then here's where our groups are. We have 8 groups of 6.48. So now that gives us 6.48 and then 6.48. Let's just put a ditto mark. This is a kind of like a quotation mark, but it means ditto. Copy what goes there. So that's 2 groups, 3 groups, 4 groups, 5 groups, 6 groups, 7 groups, 8 groups of 6.48. And when we add them, it's, well, 6.48 times 8 is 51.84, and then we just add 2. So this will give us 53 and 84 hundredths. Okay, and that would take a little bit of a worked out multiplication. Okay, but you see the difference between the two diagrams. One is 20.96, one is 53.84, but we're using the same numbers, same operations, but our grouping is different. Okay, we have 8 groups of something and 2 groups of something. So now we're going to switch gears a little bit, and I'm going to give you a set of tiles. So we have these tiles here. Okay, so how would you represent this using the grouping as these tiles seem to be grouped? Okay, well, first of all, how many different groups of numbers or numbers do we have? And we can see that they're separated by 3 different groups. Okay, so how can we describe this first one? So we can describe it as 5 groups of 1, or we can just call it 5. Okay, so let's just say that that's a 5. Now, the second set of tiles in this collection is in groups, where we can express it as a group. So what are we adding to that 5? We're adding how many groups of what? So this could be either 3 groups of 4, or we can look at it as 4 groups of 3. Okay, now the way they're set up in rows is kind of on purpose. So we're adding 3 groups of 4. And then this is, let's just call it 2. Okay, we could call it 2 groups of 1, but multiplying by 1 it is kind of not necessary. So this gives us 5 plus 3 groups of 4. There's our product, right? There's our product, which will give us 12. And then we're adding 2 to it, and that gives us a total of 19, right? So this collection of tile is equal to 19. And what separates those different numbers and groups? Those numbers and groups are separated by the plus signs. Okay, so where you see that separation, right here and right here, we see plus signs. Okay, that separates those numbers and those groups of numbers. So that comes back to what those are called. Those are actually terms. Okay, so 5 is a term. 3 groups of 4 is a term, and 2 is a term. Okay, and keep in mind that they're separated by the plus sign. Okay, so let's put that here. Terms are separated by a plus sign. Okay, so a very important concept. Terms are separated by a plus sign. And then our plus sign, well, let's put that connection to these plus signs right here. Now, the only thing that would keep that from being a plus sign that separates terms from each other is unless it's separated by parentheses. So we'll put that kind of as a side note, unless it is in parentheses. Okay, because parentheses, what that does is it says if I have a plus sign within parentheses, that makes it automatically part of a group, right? And if it's part of a group, it's part of a term, right? Because a group is a term. So let's try to remember this very important point. Okay, so unless it's in parentheses. All right, so let's practice this. Let's see if it made a little sense to us. So let's go to question B. And your task in this one is I'm going to give you an expression. And all you need to do is circle each term in that expression. Okay, so there's your expression. We have 4 times 5 plus 1 plus 3 times negative 2 plus 6. Okay, so what you should have done is first, let's identify the plus signs. Okay, so where do we see the plus signs? We see one here, we see one here, and we see one here. And we make sure that that plus sign is not in parentheses, neither is that one, and neither is that one. So our terms are 4 times 5, that's a term. 1, that's a term. 3 groups of negative 2, and 6. So those are all terms. And what this helps us to do is, like, if you identify terms, which is not, now that we look at it, not too difficult to just look for the plus signs, we're multiplying whenever we need to multiply and always adding last. Okay, so we're kind of following the order of operations as we're doing these problems. So this allows us to easily get an answer then. So there are 4 terms here. And now that allows us to say, well, that's 20 plus 1 plus negative 6 plus 6. And now we can use some of those skills that we learned in the past lessons, and that's, well, there's a 0 pair right there. That's equal to 21. And it makes things a lot more easy to deal with. All right, so let's look at a few more examples then. So this is problem C. So do the same thing. Circle the terms and find the value. So our next one is 7.08 plus 2.5 plus negative 3.84. Okay, problem D. We have 5 times negative 3/5 plus 2 times 1.5. And then the last one will be 4.32 times 2 plus 5 plus 3 1/4 times negative 1 plus negative 10. All right, so what we should see here is 1 term, 2 terms, 3 terms. For the second one, there's our plus sign. We have 1 term, 2 terms. Multiply first, add last. And the last one is 1 term, 2 terms, 3 terms, 4 terms. And this will help us to group those and add last, like we said. And this one will equal 5.74. This one will equal 0. And this one equals 45 hundredths.